Okay, let's go through today's Maths Paper 2. So Maths Paper 2 2022. And, okay, so question 1. Lovely lead-in to question 1. And they're testing your ability to add and subtract. Now, so question 1A. Now, you wouldn't have to copy out this stuff because you can just fill it in on the thing, and you've got a calculator as well, so that's obviously another definite advantage. So kind of awkward numbers. I mean, if they're going to test you, I suppose to add and subtract, there might as well be tricky numbers, but 2, I mean, this will probably be where I'll fall down the worst, is in addition and subtraction, because I don't use a calculator, and you pretty much do need a calculator for this, just to make sure. 8576, so 22714. Okay, so that's undergraduate, that's postgraduate, that's less than or equal to 23, that's bigger than 24, and that's the total. Okay, so add them up. 8, 3, 1, 14. Bloody hope that's right. And then subtract. So subtract that from that. So you get 4, 5, and what is it? 56, is it? 56. Okay, and this guy, subtraction again. Pretty onerous subtraction. Okay, so what have we got there? 7. And 0, so and it's 7,000. Okay, right. So that's it. Fill in the missing values. So now, couldn't get more easier than that. Says me not being totally sure that I've got it right, because I can't add or subtract anymore. But with a calculator, I think that's a pretty trivial question. Okay, one student picked at random from the students in the community. So total of students in the community, so is total of students in the community is this guy. O be the event that the student is less than 24. Yeah, so oh yeah, the event that the student is 24. Okay, so which kind of group does he fall into? It's this one. Let's just be clear. Okay, it'd have to be 24 or older, yeah. So it's this. Yeah, bigger than or equal to. So it's small little things like that that could trip you up on a very easy question, but that's okay. So equals 24, so it's that one. Okay, so O is the group that is 24 or older, so it's that. So it's that total. Yeah. So it's 8576 of the total of all the students. So over 22714. U is the event that it's an undergraduate. So it's an undergraduate, it will be that total. So it's 15,707 over the same total, 22714, total of students. So the probability of, are they independent? Okay, so let's just get the probability of them separately. So P of O is equal to, okay, so it's 8 over 22. Gonna need a calculator, the dreaded calculator for that one. Okay, so what is it? 8576 divided by 22714. Okay. 0.3. Question is how many significant figures, and I suppose, and that's something to just consider, but in your answer or in your question you've got kind of 5 significant figures, and some of them I don't think you'd need that many decimal places, but let's just give a fair few anyway. 0.3776, let's say. I'm going to call it a day at that point. And then P of U is 15,707 divided by 22,714. 0.6915. I normally hate having too many decimal places, but I think because there's so many significant figures in this one that I think I'm going to hold on to a lot of decimal places there. Normally once you go beyond 3 decimal places, really it's kind of meaningless, the fourth one, but let's just hold on to it for the moment. Okay. Now, so now let's get the probability that O intersection U. Bit unfortunate that U is used there, but okay, so that's that they're both probability that the student is an undergraduate and that the student is an undergraduate and is the older guy. So the old washed up undergraduate. So what is that? Undergraduate and older. So that's equal to 2922 over the total 22. So that's going to be about 10%, but let's just see. Okay, 2922 22714. Yeah, about 10%, so it's equal to 0.1286. All right, so what is this figure here? This concept P of O intersection U. So it can also be described as the probability that somebody is the older multiplied by the probability that they're an undergraduate given that they're older. All right, so let's see if we can find this figure here. Okay, because that's saying basically if they're both, then that should be equal to the probability. If they're both O and U, then it's PO multiplied by not just any PU, but it has to be, in this case, PU given that O has happened, because it's both in this case. Okay, so now we know that guy, we know this, and we're kind of trying to find that. So P of this guy, U given O is true as well, is equal to the division of the two, the intersection one over PO. So the intersection one, 0.1286 divided by PO, 0.3776. So what's that going to be? About a third. Going to be about 0.3, but let's have a look. So we're going to divide that lad by 0.3776. Yeah, so it is about a third. It's 0.3407. Okay, so 0.3407. So the probability, that's what that's saying is the probability that somebody is an undergraduate and being older, given that the person is older, is less than the overall probability. So in other words, it's not the same. So that is so P of that is not the same as the probability that person is an undergrad. So in other words, if you have the information that somebody is older, then that changes the probability of whether they're an undergrad. So they are not independent events, or they could be called, they are dependent events. So they are dependent now, and so that proves it because there's a kind of a memory involved in it. So it's influenced by other things. If the probability of U would have the probability of O would have no influence whatsoever on the probability of U. It's good to sanity check these things. In real life, if somebody is older, but bigger than 24, they are 6 years older than the average school leaver, and they're unlikely to be an undergrad. And that is true here. So there is an influence on people's age, is an influence on whether they're an undergrad or not. So they are dependent. All right. I think that's a fair enough question. Okay, people taken at random from a class. Sounds like a hostage situation. Let's see how that plays out. 3 people taken at random from a class. Find the probability that all 3 were born on the same day of the week. Okay, so Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Usually good just to sketch out these things. So there's 7 days in the week. The probability that somebody's born on one day of the week, is 1 in 7. So given that, and you're saying they assume the probability of being born on each day is the same, and that probably is true. I mean, I'd be shocked if there's a particular day in the week that most people are born on. Can't remember which one I was, but I think it was a Friday. Okay, probability of day in the week is a 7th. 3 people picked out at random from the class. All 3 were born on the same day of the week. Okay, so you have 3 people. Okay, so let's say they're A, B, and C. Well, what can possibly happen? So what are all the possible combinations that could happen? Well, so that's probability of that person being born on a particular day of the week is a 7th, a 7th, a 7th. Okay, so let's say they are born on, okay, so let's say one of them is born on a Monday, the other one is born on a Monday, one born on a Monday. The probability would be them all multiplied together. So multiply them all together and you get 1 over 21 by 7. Which is 147. So that's a pretty low probability, which is what you'd expect. So 3 people picked at random. So the first person basically is, say they're picked and so there's 1 in 7 chance that they're going to be picked on, say, a Wednesday. The next person, because you don't take out Wednesday and do it again, it's just the same. So it's 1 in 7 chance of that person as well. and 1 in 7 chance that the next person. There's no memory involved, so the fact that the person comes out as a Wednesday doesn't mean the next person's less likely to be on a Wednesday. It's just, B has no memory of A, and so on. So there we go. Okay, so let's have a look. There are B boys, B girls in the class. Okay, where there are natural numbers. 3/5 of the students in the class are girls. So B boys and G girls. So the total number in the class is, just to put that down, is B plus G. So that's the first thing, total number of people in the class. So 3/5 of the students in the class are girls. So girls is equal to 3/5 of N, which means boys is 2/5 of N, because so if you're not a girl, you're a boy, so they are mutually exclusive, so the total of them must be equal to N. So add them together. 4 boys and 4 girls join the class. Okay, so 4 boys and 4 girls join the class. So now N is changed, N is still the same, but we know the total number. Okay, so one student is then picked at random from the whole class. Probability the student is a girl is now 4/7. Okay, so probability of a girl now is equal to the total number of girls in the class now, which is 3/5 N plus 4 over N plus 8. There's 8 more people there. All right, so and that is equal to 4/7. Okay, 4/7. So let's just multiply that by, say, I don't know, 5, just to get rid of the fraction, or do I need to? Let's just multiply out first anyway. This guy, so 4N plus 32 is equal to 21 over 5N plus 28. Okay, so bring that over. So you get 20N over 5 minus minus 21 over 5N is equal to minus 4. So minus N over 5 is equal to minus 4. N is 20. Okay, nice, positive, happily positive round number, which sounds like a typical class size. So that's a good sanity. So sanity check is a good thing to do. So if you get, 5,000 people in a class as your answer, it's just good to do a sanity check on it. Most classes are between 20 and 30, so that seems about right. Okay, so that is question 1. I would say that is a reasonably good question, I think, and a fair question to do.